Hello everyone and welcome to today's lesson on relative atomic mass. Okay, so today we're going to be able, by the end of the lesson, you're going to be able to define isotope. Okay, you're going to be able to calculate the relative atomic mass, and we're going to practice some Gcse past paper questions. All right, so the equipment you need today, I would advise you to have on you a pad, or obviously if you're keeping all of your revision notes together, make sure that you've got kind of workbook with you. And I have put this in bold. Usually it's optional, but it is quite important for this lesson that you have a periodic table and a calculator. Okay, we are going to be calculating the relative atomic mass, taking into account different isotopes. So you do need to have a periodic table to hand, as well as a calculator. Okay, so if you're writing this down and kind of following these through as lessons, feel free to write down today's title and the key words as well, which is on this side. So it's isotope, neutron and abundance for today's keywords. Right, let's get started. So just to activate some prior learning, I want you to think about this question at the bottom. It says, have you heard of isotopes before? Okay, it sounds like quite a wishy-washy question, but actually it links to so many different things. Okay, so if you've heard of isotopes before, maybe you're thinking, actually in physics, I remember hearing about radioactive isotopes. Okay, and again, it's the same thing. So isotopes come up in lots of different parts of the science GCSE specification. Right, let's get started and go straight into the session. So to get your brains in gear, I would like you to have a go at this, please. So the starter is to calculate the number of neutrons in the following elements. There are 6 elements there. This is where you're going to need your periodic tables. Okay, that's all I'm going to tell you as a hint, but you will need your periodic tables. I'm not asking for the protons, I'm not asking for the electrons, I'm asking for the number of neutrons. It's very important that you're able to calculate the number of neutrons. If you need to flick back in any notes, please do so. I'm not going to give too much away because I want to explain it after. So for now, I'm just going to say use your periodic tables to calculate the number of neutrons in those 6 elements. Please pause the video now because I'm going to go over the answers in a minute. So pause the video and have a go at this activity. Okay, I'm going to go through the answers now, so hopefully you completed that. The answers are highlighted in yellow, so there were 20 neutrons for number 1, 10 for number 2, number 3 there's 8, 4 there's 48, 5, 20 neutrons, and 6, there are 6 neutrons. And this is how I did my calculation, this is how I did my working. Okay, so I'm showing my working here on the right hand side. So the answer for number 1 was 20 neutrons, and I got that answer by doing 40 minus 20. Now, some of you have kind of done that already and are thinking, oh yes, I did that as well. Some of you might be thinking, well, how have you done that? Where have you got these numbers from? And the answer is the periodic table, okay? Number of neutrons I can calculate by taking the atomic mass of that element and minusing the atomic number, okay? Let's just quickly recap that in case I've lost anyone. So every element on the periodic table has a symbol, it'll have the name, and it'll have the atomic number and the relative atomic mass, okay, or the mass number. I'll quickly show you how it might look on different periodic tables, because I know, for example, AQA and OCR have slightly different periodic tables that they give you in your GCSE chemistry. So this is how I would work it out. The atomic number, the smaller number, okay, always tells you how many protons that the atom has. It also tells you how many electrons it has, but as a definition, the atomic number is the number of protons an element has, okay? The thing is, the number of electrons can actually change, and you know, maybe you remember things about ions and you go on to things about bonding later. To work out the number of neutrons, you have to do the big number, the relative atomic mass, which is the number of protons and neutrons, and you have to take away the number of protons, which is the atomic number. So you do this number minus this number. Okay, so that is how I answered the previous questions. Very quickly, I'm going to show you the 2 different periodic tables that you might recognize. Okay, so if you're taking the AQA specification, you'll have this. This is what you are given, you know, the day that you are taking your GCSE chemistry paper. And again, they have a nice little key, so if ever you get lost, you can just use the key. But for you guys that are taking AQA, the top number is the mass and the bottom number is the atomic number. Okay, so you do To work out the number of neutrons, for lithium, for example, you do 7 minus 3, for beryllium, 9 minus 4, for boron, 11 minus 5, etc., etc., etc. For the OCR specification, it might look a little bit different, okay, because the bottom number is the mass number and the top number is the atomic number. So for you guys, you're taking the bottom, okay, 9, and you're minusing 4, for example, for beryllium, to work out the number of neutrons in beryllium. All right, so let's get back to the slides. So look at your periodic table. The atomic masses are all whole numbers. Yeah, because that makes sense. The atomic mass is the number of protons and neutrons together. So if you have a look at your periodic table, they're all whole numbers, except for an element. That element, if you got there before I did, well done, is chlorine. Yeah, is chlorine. So actually the mass number for chlorine is 35.453, or your periodic tables will probably say 35.5. Yeah, so the mass of chlorine is 35.5, so it has 35.5 protons and neutrons. That's quite strange. Okay, so the relative atomic mass of chlorine is recorded as 35.5. So that minus 17 is 18.5. Okay, so we're saying then that there are 18.5 neutrons. So chlorine has 18.5 neutrons. That doesn't make sense. You can't have half a neutron. How can this be explained? Well, it can be explained because of isotopes. Okay, so all chlorine atoms have 17 protons. They must have 17 protons because if they had 18 protons, there'd be a different element. Okay, they'd be the next element on the periodic table. So all chlorine atoms have 17 protons. It's a really key point. Some chlorine atoms have 18 neutrons, which means that they have a mass of 35. And some chlorine atoms have 20 neutrons, giving them a mass of 37. And these chlorine atoms exist, okay? So we have different types of chlorine atoms that exist in the world. Some of them have a mass of 35, some of them have a mass of 37, all right? So how are we going to put that information onto one symbol in the periodic table? Well, we have to make an average, okay? These atoms of different numbers of neutrons are called isotopes. These are called isotopes. So it's a really, really key point, okay? So keyword alert, isotopes are atoms that have the same number of protons, but different numbers of neutrons. Now I've highlighted it, I've said it's a keyword. If you are taking notes, I would strongly recommend that you write this down. If you're watching this video on your phone, maybe just say it a couple of times in your head because it always comes up. It's a really, really nice 1 or 2 marker in a GCSE question. So these are some examples, guys. So lithium, for example, okay, now you might be used to seeing this lithium because this is the one on your periodic table, but there are other isotopes that exist, okay? There are lithium-8 and lithium-6 atoms, okay, in the world. And these are the different isotopes of lithium. Now, they all have the same number of protons because look at this atomic number, but they might have different numbers of neutrons, okay? This will have 4, 7 minus 3, okay? We'll have 5, so you can actually calculate the relative atomic mass of an element if you know how much of each isotope you have. If I'm starting to lose you, stay with me, okay? You will understand this. So for example, with chlorine, I told you that there exist different types of chlorine, yeah? Some that have an amount of neutrons and others that have different amount of neutrons. So what we can do is we can calculate the relative atomic mass of an element. Yeah, we can kind of find a bit of an average and use that to calculate the relative atomic mass. This is how we calculate it, okay? So the relative atomic mass equals mass multiplied by abundance, so mass times abundance in brackets, mass times abundance in brackets plus, okay, in addition to mass times abundance in brackets. Make sure you put the brackets because it's really important when we get our calculators out and we do some of those calculations. All of that divided by 100. Again, I would strongly recommend that you write this down. All right, it'll all become clear in a second. Trust me, we'll do a few examples and you'll think, okay, yeah, no, this makes a little bit of sense now. But at the moment, I think it's a really, really good idea to write this down. Okay, mass times abundance plus mass times abundance divided by 100. Now, abundance is a fancy way of saying how much of something there is. You'll usually be given it as a percentage, okay? And let's kind of put this into practice and see what I'm talking about with an example. So let's work through an example together, and then I'll give you a few to work through by yourself. Okay, so let's have a look at this. So 75% of the chlorine in existence is chlorine 35. Okay, it has a mass of 35. 25% of the chlorine in existence is chlorine 37. So it's got a mass of 37. Now remember, to calculate the relative atomic mass, you do mass times abundance plus mass times abundance. So what I would do is I would go, okay, well, we've got a mass here of 35. I'm going to have to multiply that by the abundance, by its abundance, okay? So I would do 35 times 75 in brackets plus 37 times 25, okay? Because it's the mass times abundance plus the mass times abundance. If there was a third, we'd just do plus mass times abundance. All of that over 100. Now, if you're kind of a couple of steps ahead, maybe you've popped it into your calculator. That's probably a good idea as well, just to double check that you're getting it right and that you're understanding. You would have got 35.5 as your answer. Okay, that's the 3 significant figures. So if you do, again, if you're writing this down, it's probably a good idea to copy this example. Okay, so 75 times 35, the abundance times the mass, plus the abundance times the mass of the second isotope. All of that over 100, you should get 35.5. If you haven't got that number, it's probably because you're not using the brackets in your calculator. So please make sure you put the brackets in as well, it's really important. All right. Here is another example. Okay, so there's another worked example before I give you some to try by yourself. So the table shows the mass numbers and abundances of naturally occurring copper isotopes. So we've got the mass number, and we've got the associated abundance. So basically we've got 69% of this, and we've got 31% of this. Remember, okay, I'm going to do mass times abundance plus mass times abundance divided by 100. So I'm going to do 36 times 69 plus 35 times 31, and I'm going to divide all of that by 100 to get me this 63.6. Okay, again to 3 significant figures. If you're not sure how many decimal places to give it to, or significant figures, usually in the GCSE paper they will tell you, they'll say give your number, give your answer to 3 significant figures. If not, then you can give it to more, but I would suggest using the number of significant figures that they do in the question. So actually they've only used 2 significant figures, so you might have just put 64. Right, let's get some more practice in. Okay, so hopefully you've understood that. If I went a little bit too fast, maybe go back in the video and kind of watch a couple of the examples again. You need your calculators for this, all right? And you will need, well, that's actually it. You might, it'd be better to have obviously a piece of paper and a pen, I think, just to scribble down your answers. So we'll do 3 together, and then we'll have a go at applying our knowledge to some GCSE past paper questions. All right, so the periodic table states that the relative atomic mass of boron is 11. It has 2 naturally occurring isotopes, 80% of which is boron 11, B11, and 20% of which is boron 10, B10. Calculate the average relative atomic mass of boron. Remember, mass times abundance plus mass times abundance, all of that divide by 100. Pause the video now and have a go at this example. Okay, so I wonder if maybe some of you used the wrong number here, but it is mass times abundance. It's not number of neutrons times abundance. So actually we can ignore this extra bit of information that this question has given us. All right, 80 times 11 plus 20 times 10, all over 100, gives us 10.8. Okay, so 10.8, really well done if you've got 10.8 for the relative atomic mass of boron. Let's try another example. Okay, so the periodic table states that the relative atomic mass of copper is 64. It has 2 naturally occurring isotopes. Calculate the average relative atomic mass of copper. Again, please pause the video and have a go at this example. going to go through the answer. So if you hadn't had a go, please make sure you do so now. Okay, again, it's getting easier now, hopefully, isn't it? You're getting used to kind of the questions and how they phrase them. It's abundance times mass, or mass times abundance, doesn't matter which way you do it, plus mass times abundance. I'm going to put that all into my calculator. I'm going to divide it by 100 and I get 63.6. Okay, 63.6 is the answer. Really well done if you got that correct. Let's try one more using this format. Okay. Look at this. Okay, so this is actually a little bit different. The periodic table states that the relative atomic mass of magnesium is 24. It actually has 3 occurring isotopes. So it has 3. So 79% of magnesium is 24, 11% is 25, and 10% is 26. Calculate the average. I want you to think about what you could do if you're calculating an average, and you know before that it was mass times abundance plus mass times abundance. Remember I said if there's a third, you just do plus mass times abundance. All of that divided by 100. I'm going to give you a couple of minutes to see if you can work that out. And please do guess, even if you're not sure, I would like you to guess because I'm going to go through the answer. So pause the video and have a go at this example. Okay, so we've got these numbers in our calculation. Yeah, so if this is the percentage abundance times the mass. Again, if you swap them the other way around, that's absolutely fine. Okay, plus again the abundance times the mass plus the abundance times the mass. So we've got 3 this time. That's the only difference. Yeah, nothing else has changed. Divide by 100, 24.3. That is the relative atomic mass of magnesium. Fantastic. Okay, so I hope you've got those correct. And if maybe you've got one incorrect, just make sure that you go through that and see if your kind of calculation steps match mine and see where you went wrong. I think it's a good idea to have a go at some GCSE past paper questions now. All right, so what I've done is I've used AQA ones. So if you are following the OCR specification, it's still actually quite worth it because a lot of the questions are phrased in a very similar way. And this is actually in the specification. So the ones I am using are from the AQA specification, but if you are taking a different specification, it will be still, they're very, very useful questions. All right, so there are 3 past paper questions that we're going to go through. I'm just going to let you kind of crack on and have a little bit of a practice. So what I'm going to do is I'm going to say, pause the video now and have a go at this question. Okay, it's 4 marks. So that's actually quite a nice, meaty question. 4 marks. I would like you to pause this video. You can either, if you're watching this on your phone, as I say, you can do this verbally. But if you do have a paper and pen at hand, I'd really, really suggest that you write it down because then you can mark it and it's kind of part of the learning process. So pause the video now and have a go at this question. Okay, I'm going to reveal the mark scheme now, so make sure that is complete and you've had a go. So the first one, it says, which subatomic particles are present in the nucleus of an atom? Of course, it's protons and neutrons. Okay, it doesn't matter which way you get them around, protons and neutrons are correct. There are 2 isotopes of the element chlorine. It says, describe one similarity and one difference. All right, so this was the answer to the first question. And the second answer is that it's the same number of protons, or if you said they both have 17 protons, okay, you can say same number of electrons. It's true, it's much better, I think, to say the same number of protons, all right? But they have different numbers of neutrons. So that was that key definition that you just had to learn, all right? And in brackets, if you've obviously suggested they have different numbers of neutrons by saying 35 chlorine has 18, whereas the 37 one has 20, that's fine, you would get the mark. Right. Let's try another. Okay, so again, I would like you to read the question. This question kind of relates actually to something that's further back in the spec where we're talking about the periodic table, but I still think it's a really nice one to practice. And it links very nicely to this 3-mark question at the bottom. Okay, so I'm going to suggest that you pause the video now, read this question through carefully and have a go at answering it. Okay. So this probably took you a little bit longer, especially this question, because it's saying, you know, that they're using random symbols. These are not necessarily symbols from the periodic table. It says complete the sentence. All of the elements in the figurine are in group. You should have said 1. Yeah, so well done if you had to if you had to work that out. Maybe you've noticed that these 2 elements have 3 protons, which means they have 3 electrons. So they've got 1 electron in their outer shell. Maybe you worked it out for T as well. It's got 1 electron in its outer shell. Maybe you looked at your periodic table and said, oh, they kind of look like all of the ones in group 1. So if you said group 1 or alkali metals, that would get you the mark. Which 2 atoms in the figure above are isotopes of the same element? Explain your answer fully. Okay, so there's 3 marks available for this. So let's quickly go through the mark scheme. So this is the mark scheme for question 2. You get a mark for identifying R and S. Yeah, and again, it's just kind of following the same pattern as before. You need to basically learn the definition for isotopes. So because they have the same number of protons, i.e. they both have 3 protons, and they have different numbers of neutrons. If you did calculate the number of neutron of each, that's fine as well, that would get you a mark. Okay, one more past paper question. This is a calculation, so it's really, really good with practice. And look at this, there are 3 different isotopes. We've practiced one with 3, so we can definitely give it a go. I'm not going to give too much away. I'm just going to ask you to please pause this video and have a go at this question on the screen. Okay, I'm going to show the mark scheme, so if you haven't had a go, make sure you do so now. So really well done if you got it correct. It was 24.3, okay? And again, it's just mass times abundance plus mass times abundance plus mass times abundance, all over 100. So really well done. If you didn't show your working and you've just given the answer, that gets you 2 marks. Okay, so you can just put the answer. Right, well, I hope that was clear, okay? And I hope that you managed to achieve your learning objectives for this lesson. Thank you very much, and I'll see you again soon.